Dear learners, my name is Dr. Rajiv Kumar Misra and I am working as an associate professor in one of the affiliated colleges of Dr. APJ Abdul Kalam Technical University, Lucknow. Today we are going to discuss one of the very important topic, that is drying. We are going to discuss principles of drying and we will try to understand the science behind the drying, that is how drying takes place, particularly in food products and agriculture residues. For that I have just prepared a presentation with the following content. First, I will briefly introduce the concept of drying and then why this drying is required, especially for if you want to preserve our food for future applications, then why it is required. Then the science behind the drying. We will also discuss some of the basic phenomena in drying, like drying rates and the factors which can affect the drying rate, drying time and modes of drying. We will try to discuss different modes of drying like open sun drying, direct drying, indirect drying and so on. So in introduction, we all know that food is a basic need of human being after air and water for survival of their life. Food holds a key position in the development of any country or nation. The preservation of food for its off-season availability has been in practice since the dawn of civilization and it is not a new practice. This exercise has been done from very age-old technology. One of the oldest method of food preservation is drying of the food and to store these foods. Drying of a product is basically referred as the removal of moisture from the product or removal of some water content, removal of some liquid content from the product. Drying helps in reducing the moisture content of a product to a level below which the deterioration does not occur and one can store the food for definite period of time. Obviously this definite period of time will be maybe different for different types of foods and crops. Different crops have different level of safe moisture content at which the food product can easily be stored for longer duration. Here in this diagram, in this sketch, we just try to represent what the drying process is actually. We have wet product. Wet product will be the combination of dry product and moisture. And in drying process, what we try to do, we just remove this moisture from the wet product and after drying we left with a dry product which can be stored for a longer duration for future applications. Then what is happening basically in the wet product which need to be dried, the hot air will blow through this wet product and the humid air goes out as a result of the blowing air above the product and we left with a dry product, and this dry product which need to be dried and can store for very long duration. Various drying technologies have been developed in order to preserve the agriculture, food and products and crops. The solar drying is one of the very important and widely used drying technology which has been used from long time. Open sun drying has been the old age process of drying agriculture products and various food items. It usually requires a safe place or platform to put or rather spread the product in a form of very thin layer, and the product to be dried is spread over a surface. The sun energy heats up the product and the surrounding air and the products gets dried. In this diagram we have tried to show the actual open sun drying where the sun radiation from the sun falling on the crop, some part of the sun radiation gets reflected and some absorbed by the crop. As the sun radiation absorbs, the light energy converted into the thermal energy, the temperature of the crop increases, and as a result of which the moisture content, that is the liquid content from the crop, evaporates from the outer surface. And after evaporation, since wind and air is blowing above the surface, then this moisture, that is humid air, goes out and we left with the dry product. And the next question arises, why this drying? Why drying is required? Drying of food is basically an important process to avoid food losses between harvesting and consumption. All the agriculture products, when harvested, contain large amount of moisture and is one of the basic reason for the spoilage of the food product during the storage. If you want to store our food for our off-season applications, then if the moisture is there, then the food is likely to be spoiled. Agriculture products with high moisture are prone to fungal growth, attacks by insects, pests, etc., and the increased respiration of agriculture produce, reduction in weight, size and volume of food material. If weight, size and volume of the food material is reduced, then it is very easy to transport the food products from one place to another place, and it will be cheaper also. Then packaging requirements become simple and cheap of the dry products. So in order to overcome these problems of the spoilage of food for the future applications, the various drying technologies have been developed. In this section we are going to discuss some principles of drying, some science behind the drying. In this we will try to explain some basic technical terms. On the basis of that we can understand the principle of drying. Drying of a product is referred as the removal of moisture from product. Let us define some basic terms associated with the drying. One is moisture content and another very important term is equilibrium moisture content. So moisture content of a product is a function of both relative humidity and temperature of the surrounding air. You all must be aware of this term relative humidity. It is defined as the ratio of water vapor pressure to the saturation vapor pressure at the same temperature and is normally expressed in percentage. There are two ways to express the moisture content of a product: wet basis moisture content and dry basis moisture content. Wet basis moisture content, the wet basis moisture content expresses the ratio of moisture mass to the total mass. It is the ratio of moisture mass to the total mass of the substance, and this ratio is mathematically expressed as MWB is equal to MW divided by MW plus MD, where MW is the wet basis moisture content of the product, which is expressed in kg per kg. MW is the mass of the moisture in the product in kg and MD is the mass of the dry matter in the product in kg. So this is the mathematical expression of the wet basis moisture content. Then another basic term is of the moisture content is the dry basis moisture content. The dry basis moisture content expresses the ratio of moisture mass present in the material to the mass of the dry matter present in the material, and mathematically it is represented as MdB is equal to MW divided by MD. MdB is the dry basis moisture content, which is expressed in kg per kg. MW is the mass of the moisture in the product represented in kg. MD is the mass of dry matter in the product, which is also represented in kg. Since the total mass, that is the wet mass, is equal to dry mass plus moisture mass, and hence if M is the total mass of the wet product, then MW can be written as M minus MD, and alternatively we can write this dry basis moisture content as MdB is equal to M minus MD divided by MD, where M is the total mass, that is the wet mass of the product, that is the mass of the product with the moisture. Another very important term, if you try to understand the principle or science behind the drying, is the equilibrium moisture content. When the product comes in contact with the environment at a particular temperature and relative humidity we have already explained you, its moisture content will generally begin to change because your products gets on drying. Its moisture content will generally begin to change with time until it is finally in equilibrium with its surroundings, and the moisture content no longer change with the time. at this equilibrium condition. This moisture content is called as the equilibrium moisture content. Thus, in the simplest form, this equilibrium moisture content is defined as the moisture content at which the product is neither gaining nor losing moisture. At this equilibrium condition, the moisture, rate of change of moisture will become constant with the time. In this principle of drying, a very important term is the drying rate, that how fast or how slower the drying of your material is, the drying of your food product is. The drying of any product is a complicated process. It's not a simple process. Lots of heat transfer phenomena or heat and mass transfer phenomena is involving in this drying process, like convection, conduction, evaporation. So it's a complicated process. It's not as simple as we see that we just keep our food or some product in open sun and it starts drying. It's a complicated process. There are three main stages of drying process as shown in the figure below. Here we just try to draw the drying time with drying rate and moisture content. We can easily see there are three stages of drying: the initial period, which is also termed as preheated period, the constant rate period, and the falling rate period. In this initial period, which is represented by the region 1, the moisture at the surface of the product gets removed. We try to understand it. What is happening in the initial period? In the initial period, the moisture at the surface of the product gets removed by the heated air. The heated air starts blowing above the surface and the moisture at the surface of the product gets removed. The drying rate is slowly increasing, which is represented here in this diagram. If you see, for the first region, that is the initial period region, which is also called as the preheated period, the drying rate is slowly increasing, and there is only a very slight change in the moisture content. The moisture content, if you see, it has been represented in this purple line, and if you see for the first region, this moisture content is slightly changing. The moisture content becomes, moisture is still inside the product. It is slightly changing because moisture is still there inside the product. In the initial period, what is happening? The removal of moisture is only from the top surface of your material. And in second region, that is the constant rate period, which is represented by the region 2. In the constant rate period, the drying rate is almost constant. You can see the drying rate is constant with the time. With the time, this drying rate is not changing. In this period, the drying rate is almost constant with the time. The removal of moisture from the surface taking place while the grain temperature is constant. If the grain temperature is constant, it means the removal of moisture from the whole grain is not taking place in this region 2, and the heated air is used to evaporate the water. And the very important reason is the third reason, which is called as the falling rate period. In the falling rate period, the drying rate starts decreasing over the time. The drying rate here you can see is represented by the yellow line, by the blue line, and the moisture content is represented by the purple line. And in the falling rate period, that is represented by the third reason, the drying rate starts decreasing over the time. This is because the transfer of internal moisture to the surface takes place, and this is very slow process. The falling rate period depends upon the desired final moisture content of the product. Again, please keep it in mind that the desired final moisture content of the product will be different for the different product. Every product, every food crop have its own final moisture content. And there are some factors which affecting the drying rate. Some external factors are there, some internal factors are there. So first we will try to discuss what are the various external factors which can affect the drying rate. First is the dry bulb temperature. Dry bulb temperature is the actual air temperature measured by using a common thermometer bulb. or thermocouple. Different types of thermometers and thermocouples are available in the market, and with the help of the thermocouple we can measure the dry bulb temperature of the crop very easily. Then one of the external factor which can affect the drying rate is the relative humidity. And you know how to define the relative humidity? Relative humidity is basically the ratio of water vapor PV to the saturation vapor pressure PS at the same temperature. The temperature should be same for these two, water vapor pressure and saturation vapor pressure, and then we can define the relative humidity. And normally it is represented in percentage. The air velocity. The crop which are drying on the top surface, the air is blowing, and the air velocity, as the air velocity is more, it is more likely the moisture will evaporate from the top surface to the ambient air, and air velocity is also a very important external factor in the drying. So surface heat transfer coefficient. The heat transfer coefficient is basically, it measures the overall heat transfer ability of the material. Is a series of conductive and convective barriers which defines the surface heat transfer coefficient. And this surface heat transfer coefficient is also different for different types of crops, food, agriculture residues and all. So these dry bulb temperature, relative humidity, air velocity, surface heat transfer coefficients are the external factors which are affecting the drying rate. And you know, drying rate is a very important parameter, because if you want to dry your food very fast, then this drying rate should be faster. And some internal factors are also there which are affecting the drying rates. One is the surface to volume ratio, that the crop which we are drying, we must have this surface to volume ratio minimum is the amount of surface area per unit volume of an object. The surface temperature, the surface temperature is the temperature at or near a surface. Specifically, it may refer to the surface air temperature. The temperature on the top of your crop, the air temperature is basically the surface temperature for that crop, and the temperature of the air near the surface of the earth. The rate of moisture loss. As this rate of moisture loss is higher, your drying rate will be faster. Then last parameter in the which is the internal factor is the composition, that is moisture and fat. In wet product, what are the fractions of dry product and moisture? If more moisture content is there, then obviously the drying rate will be slow, and the product takes higher time, longer time in drying of that product to get the dry product. And another very important term is the drying time. So drying time is the total time required for the removal of water from food material, that how much time this product is taking to removal of the water or moisture from the food material. Again, I am just reminding you that this drying time will also be different for the different products, because for every product, for every food crop, there is a threshold limit for this moisture content. Drying time, it doesn't mean that the whole moisture from your crop need to be removed. There is a threshold value, there is a minimum value of the moisture content below which your material will not be expelled, and we use that material for the future applications. So in principle of drying, we need to discuss another very important term, that is drying time. Drying time is basically the total time required for drying of any product. Drying, you know, the drying is basically the removal of water or liquid from the food material. So drying time constant during the period and inversely proportional to the wet bulb depression, while drying rate is directly proportional to the wet bulb depression. We will define this wet bulb depression as the time difference between the ambient temperature and the wet bulb temperature of the air. The drying time can be represented mathematically as drying time is equal to Wt minus Wi into rho S L D divided by H into TA minus TW. TA minus TW is the wet bulb depression time. Here in this mathematical expression, Wi is the initial moisture content, Wt is the moisture content at time t, rho S is the bulk density of the solid, L is the latent heat of vapor, D is the thickness of the material which need to be dried, and H is the surface heat transfer coefficient. We have already defined this surface heat transfer coefficient is the ability of the surface of the material to evaporate the heat from the surface. Ta is the dye bulb temperature of the hot air, Tw is the wet bulb temperature of the hot air, and Ta minus Tw is the wet bulb depression. Here, if the velocity of the air is increased, so from this expression H, since this drying time is inversely proportional to the H, that is the surface heat transfer coefficient, if the air velocity is increased, then H, and hence the drying rate will increase and drying time is decreased. That is, if the air blowing above the surface of the product need to be dried blow faster, then drying rate will be increased and drying time will be decreased. Then there are some different modes of drying, and in this section we will try to understand the three different modes of drying: open sun drying, direct mode drying, and indirect mode drying. Open sun drying means we just spread our food product or agriculture residue on the surface in a thin thin sheet, you can say, and then the solar radiation directly fall on the crop. The some part of that solar radiation will be reflected, some will be absorbed by the material. Your material gets heated and the moisture inside your crop gets evaporated as the temperature increases. This is the open sun drying method. And on the top of your material, water is blowing and your moisture content will goes out with that blowing air, and we left with the dry material or dry matter. In direct mode drying, what will happen? The material or food crop will not be directly exposed to the solar radiation. We use some cabinet dryers, we use some cabinet, and in that cabinet we just put our material need to be dried, and the sun radiation will pass through a glazed surface, that is a glass, and the sun radiation falling on the glass will directly transmitted to the that glass. It will be absorbed by the material and the material gets heated, the moisture gets evaporated and we left with the drying product. Then the third one is the indirect drying mode. Here in this indirect drying mode, the point to be noted is that we will not use the sun radiation directly. We use the hot air heated maybe by the solar radiation or by other electrical or coal or other modes, and that hot air will use to dry the product. And the way how the solar energy is collected and utilized to dry the product, it defines the working principle of the drying. So here in this section we have basically discussed the introduction of the drying, then why this drying is required, and we have seen that if we doesn't dry the product and moisture content is there, so it is very difficult rather to store the material for the off-season applications and material gets spoiled. Why this drying is required? In order to overcome the problems of spoilage and all that, we need to dry your material if you want to preserve it for your off-season applications. Then we discuss the principle of drying, that what is the science behind the drying. In that we have defined some important technical terms like moisture content and important term equilibrium moisture content. Have discussed about the drying rates, and with the help of a schematic diagram and a graph, we have seen the three drying rates: initial period, constant rate period, and falling rate period. And then we have discussed the various factors which affects the drying rate. Some external factors are there like dry bulb temperature, relative humidity, air velocity, surface heat transfer coefficient, and some internal factors are also there which affect the drying rate. That is surface to volume ratio, surface temperature, rate of moisture loss, and composition, that is moisture and fat. And then we discuss the drying time, that the total time required in the removal of the water from the food material. And we have discussed the different drying modes. In this we have briefly introduced 3 drying modes: open sun drying, direct mode drying, and indirect mode drying. Okay, thank you very much.